Guys, Dr. Bevilacqua here. I just wanted to do a little movie on the potassium channel membrane embedded protein that we talked about in class today. And here's a stick view of the protein. And you can kind of see, if you look at my cursor here, that it's kind of V-shaped. It's embedded inside of a membrane, which isn't shown, but the membrane would run left to right. And here's the exterior, and here's the interior. And this particular protein allows potassium ions, and only potassium ions, to go through. And part of that is based on size, like we talked about in class today. And so I'm using PyMol. This is a program that we're going to use in both recitation and in homeworks. And we're going to start out with the sticks view. And down here on the left, I've got different scenes, different views that I've pre-recorded. And you know, it's a little hard in this view to kind of see what's going on. So we often turn to another view that we call a cartoon view. That's shown here. And you can see 4 different colors. It turns out that this protein is made up of 4 different strands. All of them are the same. So it's called a homotetramer, homo for same, tetramer for 4. And the colors tell us a little bit about the structure of the protein. These coils are alpha helices that kind of look like a telephone cord. And again, this is the exterior, this is the interior, and I can tip this and look down, or I can look from the bottom up. Let's go in and click over here on the scenes at the surface view. And here we can see that there's not a whole lot of empty space. So if I tip it again and look from the outside, we can see a tiny little hole, or what looks like there might be a hole here, but not a lot. And so, you know, with the electrons present, it's a tightly packed protein. Let's go back to the cartoon view. This is the pore from the exterior. And if I click again, I can tip it over and look at the pore. The pore is where the ions are going to go from the interior. Now let's go ahead and put those potassium ions in there. And in this view, there are 3 of them. It actually can hold up to 4, but we know potassium ions are cationic and similarly charged, and so they repel each other. And so the 4th one is kind of missing in this particular view in the experiments that were done to solve this structure. Let's tip it and look from the exterior. And here we can see they're lined up really nicely, and we can see the pores pretty tight, right? They just fit in there really snugly, and that's important for selectivity. And we can tip it again and look at it from the interior. And again, we can see them lined up in a row. And so the idea is, if I tip it back, is that this is how ions get from outside of the cell through the membrane down inside of the cell. And that's how they're selective. Again, the idea is periodic trends. Ions have different sizes, and that the cell takes advantage of this in order to set up selectivity in which ions move in and out. Thanks for watching.